In this video, we're gonna talk about the chain rule. The chain rule will allow us to find the partial derivative with respect to x and with respect to y in an easy way compared with the one that you use in calculus 1 also. So when we have calculus 1, you are having y is a function of x and x is a function of t. If you enlarge this diagram, you see that when y is a function of x, you're going to be able to find dy dx. And when x is a function of t, you have dx dt. And the chain rule in calculus 1 allows you to find dy dt. So you consider this guy as a function of t like this, and you gonna just find dy dt. And the dy dt turn out to be the product between dy dx and dx dt that we kind of use this notation similar to the fraction that when you cancel dx, you're gonna get the value dy dt. However, it's gonna be different story. It's not gonna be canceled out because they are operator. Like I told you in calculus 1, this one is gonna be just the product between the derivative of the function and the function inside. Okay, so that is going to be calculus 1. However, for calculus 2, you are having z is a function between x and y, and you have x is a function in t, and y is also a function in t. So you see that we have dz dx, we be able to have dz dy, and we be able to find derivative of x with respect to t and derivative of y with respect to t. So in this case, when you have z, okay, is a function of x and y turn out to be the function of t. So in this case, at the end, you would get the function z in terms of t. So you can plug in x and y with t. So you end up with the function in terms of t. Let me give you one example. So you have z equal to x squared minus 2xy plus xy cubed. So you see that your z is a function of x and y, and you have x is a function of t, y is a function of t. So you would get z equal to t cubed plus 1 square minus 2. X is 3 cubed plus 1, y is 1 over t, plus x is t cubed plus 1, and y is 1 over 3, and raised to the third power. So you see that you have z is a function of t, and this can be used for finding dz dt. So if you want to find dz dt, you're gonna just be able to find derivative of this guy by using calculus 1. However, you see that it's kind of messy to find dz dt, so you may need to use the chain rule, the product rule, the quotient rule or something, so it's not gonna be quite nice, okay? So we're gonna find some other ways to find derivative. This thing is called the chain rule in two variable. And you see that, okay, so you're gonna have a formula for dz dt. You have dz dt equal to dz dx times dx dt. So you follow this direction. Okay, so it's gonna be z to t in the direction of x, and you have z to t in the direction of y that allow you to have dz dy times dy dt. And then you're gonna sum these two directions up. Okay, so I'm gonna say this one is gonna be my first leg and my second leg. Okay, so it's gonna be the first leg and the second leg that I have, and I'm gonna have dz dx times dx dt plus dz dy times dy dt. Okay, so this one can be done in the way that you have dz dt. Okay, so it's gonna be dz dx plus not dz dx dx dt dx dt plus dz dy times dy dt. Okay, so you have dz dt equal to dz dx times dx dt plus dz dy dy dt. And you see this guy is the pink guy, okay, and you see you end up with dt at the end. Okay, so this one is the formula. You don't need to memorize the formula. The formula can come from this diagram. So basically, you just draw a diagram that represent the variable that you have set is a function of them, and you have x is a function of t and y is a function of t, and this will allow you to be able to find the z dt. Okay, so I'm gonna just make this guy smaller. I'm gonna just make this guy smaller, and I'm gonna have this one. Okay, so I'm gonna just find dz dx. So you have dz dx. dz dx, you just differentiate this guy. So it's gonna be differentiate with respect to x. So this one will be 2x, right? So it's gonna be 2x minus 2y. Okay, so with respect to x, 2x minus 2y plus y cubed. Okay, so it's gonna be 2x minus 2y plus y to the third. Okay, and you have the x dt, so this one is going to be 3t squared. So basically, so this one is going to be 3t squared. Okay, I'm going to highlight the pink one. The second one is going to be dz dy. So you differentiate with respect to y. So you would get 0 minus 2x, and it's going to be 3x y squared. Okay, so it's going to be 0, 0, and it's going to be minus 2x plus x times 3y squared. Okay, and this one is dz dy, and for dy dt, so you differentiate 1 over t. So this one, count 1, is going to be negative 1 over t squared. Okay, so that my derivative with respect to t. So this one will be just derivative of this guy, okay, with respect to y, with respect to x, and you have the x dt and dy dt. Okay, so that is going to be 2 terms. And you like to find dz dt at t equal to 1, dz dt at t equal to 1, dz dt t equal to 1. So for this one, you're gonna have to plug in, okay? So you see that you can plug in t equal to 1, okay? So you're gonna plug in t equal to 1, t equal to 1 here, okay? So that's quite easy. However, you're gonna have to find x and y when t equal to 1. So you're gonna have x equal to 1 to the third plus 1 equal to 2. Okay, so that is our x. Okay, and you have y equal to 1 over 1. So it's gonna be 1. So you have x equal to 2, y equal to 1. Okay, so this is gonna be, so you would get 2, and you have x equal to 2, okay, minus 2 times 1, and you have 1 to the third. Okay, so that is going to be our x and y. And you have 3 times 1 square, 3 times 1 square. And you're gonna add negative 2 times 2 plus 2 times 3 times 1 square. Okay, so that is gonna be your put x equal to 2, y equal to 1 into the formula, and you have negative 1. Okay, so you're gonna have negative 1 for the last term. Okay, so you end up with the numbers. Okay, so it's going to be 2 minus, so it's going to be 4 minus 2, so it's going to be 2, so it's going to be 3, so you would get 9. Okay, so you would get 9 total. Okay, so the first guy will be 9. The second guy will be 6 minus 4, so it's going to be 2, and you have minus 1, so it's going to be minus 2, and the number would be 7. Okay, so this one will be the final answer. So you have d z dt at t equal to 1 turned out to be 7. For the second one, okay, for the second one, you have z is a function in terms of x, y, and w. So it's going to be 3 functions. So let me draw the diagram. Okay, so you have x, y, w, and you have x equal to 2t, so it's going to be t. Y turn out to be equal to t squared, so it's going to be y is a function of t as well, and w is also a function of t. Okay, so this one will be z will be 3 function in 3 variable x, y, and w, x and y turn out to be a function of t. So at the end, z will turn out to be a function of t. So for this one, you have dz dt. By the way, I forgot to tell you that when you have the function in one variable, okay, we're going to use the normal d. Okay, so we're going to use the normal d because we are talking about z and t, and you see that at that level it's going to be just t, so you not have partial derivative, it's going to be just derivative. However, if you have this level, when you have level x and y, you're going to use the partial derivative because it's function in 2 variables. Okay, so the notation a little bit different on the d. One d turned out to be the normal d, another one turned out to be the curly d, so it's going to be the partial one. Okay, so for this one, you don't need to memorize the formula, you just follow the diagram. So you have the z dx times dx dt, okay, one variable, plus dz dy dy dt, and you have dz dw dw dt. Okay, so you have dz dt equal to dz dx, dx dt plus dz dy, dy dt, and dz dw, dw dt. Okay, and you gonna just find dx dt, dy dt, and dw dt. Let me highlight them. Okay, so it's gonna be this color that you are working with. Okay, so you're gonna find first the z dx. Dz dx is gonna be differentiate these two guys, so you would get just 2x plus cos xw times w. Okay, so that's gonna be the partial derivative with respect to x. I would let you find these two guys. Okay, so it's gonna be, I'm gonna just have in this form. So you have the x dt, the x dt, so it's gonna be 2, right? So the x dt is gonna be 2. So it's gonna be like this. Okay, so for this question, so I'm gonna leave you with something like this, and I ask you to fill this one for me first by yourself. Okay, so I'm gonna just leave you in this one, and you gonna just fill the color for me. Okay, and then I also see this one that, okay, so I also see in this one that you would have uh, you have x to t and sec t. So for this one, it's going to be just dx, dz, dt, and you don't need to plug in anything. So this will give you just the final answer. Okay, so let you do this one, okay, and then I give you the solution during the recitation. Okay, now we're gonna go to the chain rule in the second case. In the second case, you see that you don't need to know any formula, you just see the diagram. So you have SAT is a function in two variables, x and y, and you have x is a function, okay, x is a function in terms of u and v, and y is a function in terms of u and v. So the color will be, you have two color like this. So you have SAT is a function in terms of u and v, and SAT is a function in terms of x and y are the function in terms of u and v. So for this one, you're gonna see that you have the leg that SAT is a function of u. So you have one leg and two leg. So you'll be able to find the SAT du. You'll be able to find the SAT du. I use the green color, and you see that when you like to find the SAT du, you don't need to memorize the formula. You just follow the diagram. So you're gonna have this leg and this leg. Okay, so you have these two legs, and it's going to be the product between dz dx and dx du. Okay, let me enlarge this one. So it's going to be the product between dz dx du plus dz dy and dy du. Okay, so it's going to be just easy like this one. Okay, so you just follow the diagram, no need to memorize the formula. The second one will be, you have the z dx dx dv plus the z dy and dy dv. So this one will be the pink color. And you see that for the pink color to be correct, you're gonna end up with dv at the end all the time. Okay, so let me use the pink color for these two guys, and you see you end up with dx du and dy du for the green color. So we basically follow these two legs. Okay, so we not have any formula to memorize. The thing that you're gonna be able to do is gonna be just, you're gonna try to draw a diagram that relate the variable that you have here, and then you're gonna just follow the diagram. So for this one, you have SAT equal to e to the y sine x. So you have SAT is a function in terms of x and y, and you have x is a function in terms of u, v, and y is a function in terms of u, v. Okay, so let me highlight some color. So you have u, you have V, okay, you have U, you have V, C is, the C is nice color, and you're gonna be able to find the Z, du, okay, so this one I highlighted green, and the formula will be, turn out to be just follow this diagram, so it's gonna be Z x, xu, okay, plus ZY, yu. So it's going to be dz dx dx du plus dz dy dy du. Okay, so it's going to be z x xu, and this one will be the green one that you need. Okay, so it's gonna be dz du equal to dz dx dx du plus dz dy dy du. And then you have dz dx. Okay, so you're gonna just differentiate this one step by step with you. So dz dx is gonna be dip e to the y sine x. So this one constant, right? And you just dip sine x, dip sine is cos. So it's gonna be e to the y times cosine x. Okay, so it's gonna be e to the y cosine x. Okay, and dx du turn out to be 3u square v square. Okay, so it's gonna be 3u square v square. Okay, so this one is highlight green, highlighted green, and you have the z dy. Okay, the z dy is gonna be e to the y sine x, and you have the y du, so you dip y with respect to u, so you just have root v, and dip log u is going to be 1 over u, so it's going to be root v over u. Okay, so it's going to be this green color. Okay, so this one is going to be final answer. Okay, so you have this one correctly. So you see that you need just 4 partial derivative, which turned out to be quite easy. No need to memorize the formula. So you just use the diagram in order to get the formula, and you basically just differentiate 4 guys, and you're basically done. Okay. Another one is the z dv. You have the z dv. For the z dv, you follow this leg. Okay, so it's going to be dz dx, and you have, dz dy and dy dv. So it's going to be dz dx dx dv plus dz dy dy dv. Okay, so it's gonna be like this. I have 2 pink terms here. Okay, so you see that, hey, for this term, do you see, do I have dz dx? Do I have dz dx? Of course, you have dz dx, and dz dx turn out to happen again for this formula. You see, the color I use is the same. Hey, it's gonna be the orange guy, okay? And can I just copy it down? You don't need to differentiate it. So basically, you just copy the orange guy down, okay? So it's gonna be e to the y cosine x, okay? So this one is the same thing. However, for dx dv, you need to differentiate. So you have dx dv, so it's going to be u to the third time 2v. Okay, so this guy is going to be u to the third time 2v. And you also see that, hey, do we have dz dy? Do we have dz dy? Of course you are. And do you have, so it will be dz dy turn out to be e to the y sine x. It's correct. So for this one, it's gonna be just e to the y sine x. Okay, so it's gonna be e to the y sine x, and this guy is the blue one. Okay, and you have dy dv. Okay, so dy dv, so you differentiate this guy with respect to v, so it's gonna be constant. Log u is log u, 1 over v is the root v is gonna be 1 over 2 root v. So for this one, it's going to be 1 over 2 root v. Okay, and you have log u. So for this one, it's gonna be the orange one, and that's all. Okay, so this one will be just the thing that you have. So you see that the formula, you don't need to memorize, you just recognize the formula by using the diagram. Okay, so that one thing. And when you like to find derivative, you see that d at dx will be repeated in the second one that you have. Okay, so the first one is d at du, the second one is d at dv. However, the partial derivative turned out to be repeated, so you don't need to differentiate d z dx again. So you may just copy the d z dx down, similar to d z dy that you can copy it down. Okay, so it's going to be just 1, 2, 3, 4, 5, 6 derivative in total that you have to be able to find. Okay, so that is the chain rule. Let's do one more. So you have w, okay, equal to x squared plus psi yz e to the x. So for this one, you have w is a function in terms of x, y, and z. Okay, so you have w is a function in terms of x, y, and z, and you have x is a function in terms of uv, and y is a function in terms of v only, and z is a function in terms of u and v. So you see that you have 2u and 3v for this function w. So by using the chain rule, you're gonna be able to find dw du and dw dv. Okay, so you have dw du, dw du. So this one is the green color, dw du. And dw du turn out to be dw dx dx du plus dw dz dz du. Okay, so you have dw dx dx du dw dz dz du. So this one is the green color. Okay, and you see that you need 4 partial derivative in order to complete the solution here. So you have dw dx, dw dx, so you differentiate this guy with respect to x, so you have 2 terms. So it's going to be 2x minus e to the x. Okay, so it's going to be dw dx, and the dx du, so you get v. Okay, so dx du, you get v, v here, v, and let me highlight green color, so it's going to be just dx du, and you have dw dz. Okay, so dw dz, so the first term and the second term disappear, so it's going to be cos yz times the derivative with respect to z, so it's going to be y. Okay, so this one is derivative, so you differentiate yz with respect to z, you have y constant. Okay, so that's why you have y left, and then you're gonna multiply this whole thing with dz du, dz du, so dz du turn out to be just cosine v. Okay, so it's going to be cosine v, and that's all. Okay, so this one. So you have the w du, okay, equal to this one, and you're gonna plug in u equal to -1 and v equal to 0. Okay, however, you see that the w du at -1, 0. So you put u equal to -1 and v equal to 0 into the function that you have. However, for this guy, you must find the value for x, y, and z to put in also. So you're gonna have to solve for x, y, and z. So you have x equal to u times v, so it's going to be negative 1 times 0. It will be equal to 0. Let me write it down here. Negative 1 times 0 equal to 0. And you have y equal to log v equal to 0. So it's going to be 0 squared plus 1. So it's going to be also 0. And you have z equal to what is u is negative 1 and cos 0. So it's going to be negative 1. Okay, so you have x equal to 0. Y equal to 0 and z equal to negative 1 for you to plug into the function. And you see that when you plug everything in, it's going to turn out to be 2 times 0 e to the 0 times v. V is also 0 plus cos yz, so it's going to be 0 times negative 1 times 0, and you have cosine v is cosine 0, so this guy is equal to 1, okay, equal to 1, and the whole thing become 0, okay, so the whole thing becomes 0, so this one is your the w du at negative 1, 0. Okay, so this is how we do this one. The second one is the w dv. Okay, so the w dv. And for dw dv, so you have dw dx, dx dv, so it's going to be 3 legs in this case. So it's going to be 3 legs. So you have the w dx, dx dv plus dw dy, dy dv plus dw dz, dz dv. Okay, so you have 3 of the pink color. Okay, so you see from 3 legs, and you're gonna find the w dx, dw dx, so you just have 2x e to the x, okay, dx dv, so it's going to become u plus dw dy, okay, so this guy will be cos yz times z, and dy dv, so it's going to be 1 over v squared plus 1 times 2v, okay, so it's going to be times 2v plus the w dz, okay, the w dz, so it's going to be cos yz times y, okay, and you have dz dv, so it's gonna be u, and you're gonna get dip cos, you get negative sine phi. Okay, so they will be pink color. Okay, so they will be pink color like this. Okay, so that is going to be 3 terms that you have. Okay, and then if the question just asks you for dw dv, this is your final answer. However, the question asks you to plug in u equal to negative 1, v equal to 0, okay, negative 1, 0, and you have x, y, and z, okay, so you're gonna plug them in for me. So you have the w dv at negative 1, 0. So you're gonna plug in, so you're gonna get 2 times 0 minus e to the 0 times u equal to negative 1 plus, okay, for the last two terms, you see that you have v equal to 0 and you have psi v equal to 0. Okay, so here v equal to 0, v equal to 0. This guy will force the calculation turn out to be 0 and 0. Okay, so they will disappear and the thing that will survive turn out to be just the first term, and the first term gives you the final answer equal to 1. Okay, so that's all basically. So for this one is called the chain rule by using just just it's going to be the formula for the chain rule. Okay. So I will leave you number 3 for you to do this one on your own first, and we gonna just give the solution during the recitation. This one will be not 0 for both of them. Okay, so try to be careful on the derivative and try to follow this example. It's pretty much the same thing, easier, I would say. Okay, so basically just sketch the diagram and you'll be able to obtain. Okay, let me first introduce you. So the diagram that you will get will be z is a function in terms of uv, and u is a function in terms of x and y, and v is a function in terms of x and y. So for this one, you see that you can highlight two color and you'll be able to just follow the diagram in order to obtain the formula for dz dx and dz dy. Okay. The last thing that we're gonna have here is gonna be about when you have the z is a function in terms of x and y, and you like to find derivative of z with respect to x and with respect to y, but the function z cannot be written explicitly. So this one is implicitly defined. Okay, so this one is called implicitly defined. So it's going to give you the relation in terms of x, y, and z instead. It's not z equal to, okay, so it's not z equal to. So it's going to be different from the previous example. The way to obtain the partial derivative turn out to be using the chain rule by letting the new function, okay, so you're gonna just make one side to be equal to 0. So you're gonna just have y squared minus e to the y, e to the 2y sine x minus z squared equal to 0. And you will declare the function capital F, X, Y, Z to be the function on the side that not equal to 0. Okay, so that is going to be the function in 3 variables instead of 2. Let's see this one. You see that this one look innocent. However, this one is not quite easy to do. So for this one, it's going to be square root x sec y minus log z to the third plus x equal to 0, and you can declare this function to be the function capital F x y z. Okay, so this one will be your f x y z. Okay, so with me so far, so you just have the relation in x, y, and z, and you just make one side equal to 0. You can move this guy to the right side as well. However, it doesn't matter. At the end, the final answer will turn out to be the same anyway. Okay, so for f, x, y, z, you just make one side equal to 0. And the way to obtain the solution for this guy turned out to be by considering this diagram. you see that for this diagram, the capital F turned out to be the function that depend on x, y, and z. And you have z is a function in terms of x and y. So if you follow the chain rule, so you see that you have two legs. Okay, so you have two legs. So you're gonna just have the f dx. You have the f dx and you have the f dx and you have the z dx. Okay, so this one will be just these two guys, and you differentiate this one. Okay, so this one come from, you have the f x, y, z with respect to x equal to d0 with respect to x. Okay. How did this guys come from? This guy come from here. So you have this one equal to 0 and you dip with respect to x both sides, d0 dx. Okay, so that is going to be one term that you can have, and this follow that. So you get this guy equal to the green color. So you see that you have this term and you have this term. Okay, so this one is going to be follow the green leg. Okay, one leg, two legs. Okay, and this one turned out to be d0 dx, it will be 0. Okay, so d0 dx it will be 0, and this is how we obtain this guy. Let me make this guy smaller. Resize and then move it here. So, and I'm gonna color this guy with the orange one. The next one will be, you're gonna have the f dx. Okay, so you have the f the you're gonna have the f dy, and you're gonna have the f dy. So this guy will be d0 dy, d0 dy. So for this one, it's gonna be the f x y z dy equal to d0 dy. Okay, and d0 dy turn out to also equal to 0. Okay, so d0 dy turn out to be equal to 0, and this one you follow the pink leg. So you have this guy and you have this guy, and the question asks you to find the z. Okay, so the question asks you to find the z dx. Okay, so we need the z dx, and we do need the z dy. Okay, so we need the z dx and we need the z dy. Let me use some other color that is going to be clearer. So you need the z dx. So the way to obtain the z dx turn out to be, you see that you just move to the other side. Okay, so you see you can just move. Hey, do we move the f dx to the other side? Yeah, you can. And you have negative side come from that move, and then you divide the f dz. Okay, and you have the z dy. The z dy can be obtained from, you move the f dy to the other side and you divide by the f dz. Okay, so this is the formula that you have. Normally we memorize this one as the z dx equal to negative fx over fz, and you have the z dy equal to negative fy over fz. Okay, so it's going to be just two formula to memorize. So this is how we differentiate the function implicitly. Let's do one example. So you see that I declare the function capital F, X, Y, Z already, okay? And we're gonna compute dz dx. dz dx will be negative fx over fz. So it's gonna be negative fx over fz. So you would just differentiate this guy with respect to x. You differentiate this guy with respect to x. What do I get? It's going to be 0. Okay, so it's going to be 0. It's going to be differentiate with respect to x. So you get cos x. And this guy will become, again, 0. Okay, so this one will be 0 minus e to the 2y cos x minus 0 over, okay, and you differentiate the term with respect to z, so you would get 0 minus 0, differentiate z square, you get 2z, okay, so this one will be just negative become negative, and you have negative e to the 2y cosine x over negative 2z, okay, and for this one you can just cross this negative sign out, okay, and this will allow you to have final answer. Okay, pretty easy actually. The next one, you need the z dy. The formula will be fy over fz, and fy will be, you differentiate this guy with respect to y, you would get 2y e to the 2y times 2 sine x and 0. Okay, so that will be your partial derivative. It's going to be 2y e to the 2y times 2 times sine x, and you have minus 0. Okay, so this one will be f with respect to y, the capital F with respect to y, and derivative with respect to z will be, actually you can just copy this term down, so that will be 0 minus 0 minus 2z, okay, and your final answer turn out to be negative 2y e to the 2y times 2 sine x over negative 2z, and you see that they get rid of, okay, so you're gonna just get this guy to be your final answer in this form. Oh, by the way, you can just get rid of 2. So it's going to be y e to the 2y sine x over z. Okay, pretty nice. Okay. Again, I let you do this one on your own. Okay, so please try to find dz dx and try to find dz dy. We do this one during the recitation, okay, to check whether you have them correctly. The final one, okay, please read the question. Okay, so please read the question. This one comes from chemistry. And the question asks you to calculate dt dp and dp dv. Okay, so this one will be just one, I wouldn't say difficult. So for this one, it's going to be a little bit complicated. I give you some hint first and then to see whether you'll be able to get it. So you obtain me f of p, v, and t. Okay, so equal to 0. Okay, find the capital F, P, V, T equal to 0 by doing the same thing as the previous example. And you're gonna have dt dp, okay? And you have dp dv. By just use the formula, this one will be fp over ft, okay? Derivative with respect to p and the partial derivative with respect to t. And this guy will be f with respect to v and f with respect to p. Okay, so you see that the formula is kind of reciprocal. T on top turn out to be on the bottom. P on top turn out to be come from the bottom P. Okay, so this one will be just the formula that obtained from this formula. Okay, so that is come from here. So you're gonna just find the capital F, okay? It's gonna be the function in terms of P, V, and T, and you have constant, okay? Constant turn out to be N and A, okay? So A turn out to be positive constant and B also constant. Okay, so you try to find dt, dp, and dp, dv by just find the negative of fp over ft and negative fv over fp and do basically that. Okay, so that's all for this script. Okay, so you do this one and we're gonna discuss this guy again during the recitation.